Yo dudes, a number of people have asked me about how to solve a problem like this, where we are told, hey, a mixture of two isotopes have an average atomic mass of blah. What is the percent abundance of blah? Well, I want to walk you through how to attack a problem like this right about now. So, the way I'm going to do this is, first of all, let's talk about how we're going to get our weighted average mass, or our average atomic mass, normally. Or on the other side of the way we've seen problems like this. Let's start with an imaginary thing. We've got isotope A and we've got isotope B. We know that isotope A has a mass of, why don't we just say 3, and isotope B has a mass of 4. And we know the percentage of A, I'm just trying to move the mouth. What a goober. We know the percent abundance of A is, why don't we put it in decimal form, and we'll say 0.75 or 75%. And we know the abundance of B is 0.25. What I would do is I'd multiply these together, the mass by its percent abundance, and I'd add that up to get my average mass. Well, we can't really do that. We're doing the opposite of this. We're going from an average mass backwards. And what's challenging about this is that we don't know either of the percentages. There are two unknowns presently. We don't know the percentage of A, and we don't know the percentage of B. But you know what we do know? We do know that the total percent is 100. I do know that my percent of A plus my percent of B is going to equal 100%. Or a better way to think about that for this problem is to put it in decimal form. So I'm going to say it equals 1.00. Now what I can do from here is be a little bit crafty, and I can say that, you know what, let's subtract percent A from both sides. I can say that percent B is equal to 1.00 minus the percent of A. Ooh, that's some neat stuff. You know what I can do now is I can just substitute this in anytime I say percent B. So maybe let's write this in a slightly different way, because the math I would do to catch my average mass at the end is going to be 3 times the percentage of A plus 4 times the percentage of B. That equals my average mass. Well, I can substitute this in, because right now I can't solve this. They gave me the average mass. In this problem, I've given the average atomic mass. But if there's two unknowns, I can't solve for that. But what I can do is do some substitution. If we get rid of this B, we replace it with this term here. Let's do that really quick. I know that the percentage of B is equal to 1 minus the percentage of A, so I'll say 1.00. We'll do 4 times 1.0 minus the percentage of A, and that's still equal to my average mass, which the problem gives me. Well, now I should be able to solve this. There's only one unknown in here, percent A, and everything else is provided by the question. Wow! There's one other thing you might be asking. You might be like, bruh, how do you get the masses for these two things? Well, in this particular example, let's see, we've got 120x, x with an atomic mass of 120 AMU, and we've got x 122. This has a mass of 122 AMU. That is all you need to solve a problem like this. Yeah! Woo! Bye. Check it out, my ding-dang dudes. It's some, I believe this is a chicken fat mushroom. Boing, 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 boing.